History review part 2. I saw the last video was getting kind of long, so I went ahead and chopped it and put it into 2 pieces. So, in case I mess something up, I wouldn't mess the whole thing up. Okay. Number 10 tells us to figure out the graph of this exponential function, 7 to the x. And if you remember what exponential functions look like, we can go ahead and pick the graph without even doing any values. We can figure out, right, the exponential functions look like this, unless if they haven't been shifted or reflected or anything, they're going to look like that. So that's our graph. Let me do a different color since the graph's in red. There we go. But let's look at our table of values. All we're doing here is we're plugging stuff into our calculator. Sorry, I don't know why this is being so glitchy today. There we go. So for the first one, we'll do 7 to the negative 2. And you can just plug that in your calculator, but here that's the same thing as 1 over 7 squared, or 1 over 49. So, yeah. And you can use a calculator. Okay, that's fine. 7 to the negative 1, that's going to be 1 over 7. Anything to the 0th power other than 0. Anything to the 0th power is 1. 7 to the first power, that's 7. 7 squared, that's 49. That would be our table of values. Remember, if you just remember the basic shape of exponential, we don't even have to worry about that table of values for these choices. Okay? Because an exponential function, it's always going to have a special point on there. It's going to have the point 0, 1 if it hasn't been shifted. And then it's going to be really small on the left and get really big as it goes to the right. That's our basic shape. Okay. 11 is match the exponential function with its graph. My suggestion on these is to figure out what just the plain exponential function without any transformations done to it first. Okay. So I'm thinking about this one, just 2 to the x, no negatives in there anywhere. So what's that going to look like? That's going to be this one. So this first one's going to be graph 3. Okay. So then we can think about transformations. Usually what I like to look at next is what if we put a minus sign out in front of the whole thing? What's that going to do? That's going to change everything that was positive to negative. So that's going to be an x-axis reflection. So that's going to be this graph. So that's going to be graph 2. Then I think about, okay, what if we just have this negative sign in here with the x? Since that's on the x, that's going to be a y-axis reflection. So that's going to shift everything. The left side's going to be the right side's going to be the left side. So that's graph 1. And then the last one, we know what it's got to be. But let's look at what's happening. So it's doing a y-axis reflection with this negative sign and an x-axis reflection with this negative sign. So we switch the left and right sides, and we switch up and down. That's going to be graph 4. Number 12. Here we're just using the calculator. Okay. So it just tells us, what to use for our exponent. So I'm going to do 4 to the 1/2 power. Okay, and that gives me 2, but it says round to 3 decimal places, so this is going to be 2.000. Then I'm going to do 4 to the square root of 3 power. There I got 11.036 when we round, it rounds up. Okay, then I'll do 4 to the negative 2 power. Here I got 0.06 and it rounds up to 3. And then I'll do 4 to the 0.4 power. Here I get 1.741. And so just straight up calculator problem there. Just need to know how to do exponents in your calculator. 13, we're switching from logarithm form to exponential form. So what I start with is the base. So this says base 6, so that means in exponential form I'm going to have a big 6, and it's going to be to this power. This says 6 to the first power equals whatever was inside the logarithm. So for here, 6 to the first power is just 6, so 6 equals. Again, I'm going to look at the base on part B, so I'm going to have a big 10, and that's going to be to this power. So 10 to the 2t power equals whatever was inside the logarithm, so that was 3. That's all we're doing. We're not solving for anything, we're just switching the form. (14), we're just going the other direction. So here I'm going to look at my big number, my base. I know I'm going to need log base 3 of this, the 50, and equals x, that's my exponent. Here again I've got log base 3 of this, of w, that equals 5, what was in the exponent. Okay, so again, not solving for anything, we're just switching the form. Last problem here, if we can get this to show up. So similar to what we did with exponentials, but we're dealing with logarithms here. Remember, logarithms, if they haven't been shifted or reflected or anything, they're going to have the point 1, 0 on their graph. That's the special point for logarithms. Okay, so I'm going to start with just the regular log graph, no reflections. So that's going to be graph 3. That's what a logarithm looks like. It starts out really close to 0, down toward negative infinity as you get close to 0, and then it grows as you go to the right, and nothing's on the negative side of the graph. Okay, so this first one is going to be graph 3. Okay. If we put a negative in with the x, that's going to be a y-axis reflection, so everything that was on the right side is going to switch over to the left side, so that's going to be this one, graph 2. We put a negative out in front of the whole thing. What was at the top is going to go to the bottom. What was at the bottom is going to go to the top. That's a x-axis reflection. So this is going to be graph 1. And then we're going to do both on the last one. So we're going to switch it over. We're going to do a y-axis reflection. We'll get that. Then we got to flip it over the x-axis, so we end up here, graph 4. And so it's just knowing your reflections and knowing what the basic graph of a logarithm is. Okay, so that's it on the practice test. Okay, shouldn't expect any surprises on test 3. I'm not trying to surprise you. I'm just trying to give you another chance to improve your grade, giving you this third test. Okay, let me know if you have any questions.